Hello guys, today's video is going to be on how do we find sequences, expressions, and also making tables for them. I apologize for my voice, I'm still a little sick, so just bear with me. So first we need to talk about certain vocabulary words that we need. So the first vocabulary word that we need to talk about is what a sequence is. Well, a sequence is a number are numbers that are in sequential order that have a pattern. So I made an example for you. I have 5, 13, 21, and 29. These numbers all have a pattern. Okay, so let's discuss what that pattern is. From 5 to 13, 13 to 21, and 21 to 29, there's something going on. Okay, what pattern do you notice? Well, from 5 to 13, we are adding 8. And from 13 to 21, I am also adding 8. Then from 21 to 29, I added 8. So this is considered a sequence because there's a pattern going from one number to the next. Okay, let's go ahead and look at the next, vocabulary word. Next vocabulary word we need to look at is what n means. N represents the position in the sequence. Okay, so I gave you an example. Here's another sequence. We have 2, 7, and 12. The pattern here is that we're adding 5 every time. Now, the n is going to be stating the position that it's in the sequence. So, for example, this first number is in first place, therefore the n for it would be 1. The second number, since it is in second place, my n for it is 2. This third number, which is 12, since it's in the third place, the n is 3. Okay? So that's what n represents. It's super important for you to understand it because it's when you don't get this basic concept that you get the wrong answers. Okay, and you will see in a little bit why the n is so important. So let's go ahead and take a look at next vocabulary word. We're almost done. Next vocabulary word is the word expression. Okay, an expression is kind of like the equation that we use to find the terms in the sequence. So an expression can be anything, for example, 2n plus 5. This is our expression that we use to find each of the sequence. Okay, and I'm going to show you in a little bit how do we actually use this to find each of those numbers in that pattern. Okay, so let's go to the next one. Last word we need to know is a term. A term is any number that is included in a sequence. Okay, so for example, in the sequence 2, 5, 8, each of these numbers is called a term. So each of those would be considered a term. Okay, so now let's actually talk about the math. Why are all these vocabulary words important? Okay, if you notice here, guys, I have put 4 different kinds of problems. Now, the reason I chose these is because these are the 4 ways that you'll be tested on sequences. Okay, the first way, so this one over here, this first way is about, so let me zoom in so you guys can see it better. This first way, guys, is they're giving you the expression. So right here, they're giving you the expression. Right here, wait. They're giving you the expression up here. And then they're asking you to find the sequence. That's the first way that they can test it. Okay? The second way that they can test it is something like this. They're giving you a table, or they can write it out, and they want you to come up with the expression. Okay, that's another way that they can test it. we also have this way, which is they're giving you each of the numbers in a table, asking you to find the expression. And the last way is they're giving you the rule, and they want you to find what would be the numbers in the sequence. They're giving you the expression or the rule, and they want you to find the numbers. Okay guys, so let's continue. Let's go ahead and look at this first example. In this one, guys, we have the rule. They're giving us 2n plus 1, and it states specifically n is the number's position. Okay, they're not trying to trick you. They're reminding you. Anytime, guys, that you get a problem, this is what I want you to remember. I want you to make a table, always. If there is no table, make one. The tables are going to help you make sure that you're getting the right answer. Okay, so in this case, guys, our table will always be an n and a number. It could look like that, or you could write it like this, like a T-chart. They're both the same. Okay, so again, either one doesn't matter. I'm going to go ahead and use this top one. So, how do we fill this out? Okay, so we have n, guys, which is representing the position. Okay, so first position in first place. Okay, so in first place, I want to find the number that's the first. Okay, to do that, I'm going to have to do some math. This is telling you that n is now 1. Okay, so I'm going to plug it into here where I put the little arrow. So 2 times 1 plus 1. That gives me 2 plus 1, which is 3. So I put in a 3. Okay, now I want to find the second number. So I'm going to put in this 2. Where this n is, I'm going to be putting in here a 2. So now I'm going to do 2 times 2 plus 1. So that gives me 4 plus 1, which is 5. And I'm already finding my answer because the first number should be 3, second number should be 5, and the only one that matches is this one. First number is 3, second number is 5. So I have found my correct answer. Okay, let's go ahead and look now at another problem. This next problem, guys, is a little bit different. Okay, they're showing you the expression and they're giving you a table. So in this problem, guys, they're giving you a table. We don't have to worry about making it. We just need to make sure that these are right. Okay, so let's go ahead and try this. First one, just like we were doing before, guys. I'm going to do my work over here, just so I can make sure I'm doing everything okay. My first number, again, here's my n. I want to make sure that I am plugging everything in. So into that n, so I'm going to do 4. Remember that a number next to a variable means to multiply. So I'm doing 4 times 1 minus 3. 4 times 1 minus 3, that gives me 1. Okay, right away, the first one that I know cannot be this one. Okay, cannot be this one, and can't be that one. Look at that. We just solved this without even having to continue. Could I continue just to be absolutely sure? Sure. If I wanted to know the second number, I'm going to plug in a 2. 4 times 2 minus 3. That gives me 8 minus 3, which is 5. Did it work? So far, so good. And I can try it for every single one to make sure that I'm getting it the right answer. Okay. Let's do one more. Well, 2 more. On this one, guys, they're giving you a table and asking for the expression or the rule. Okay. So we first need to find out what is going on here. Okay. So I can see that there's a pattern here, right? The pattern is to add 5 every time. Now I know that the first thing you're going to think of is, well, that's n plus 5. No, you guys, we cannot say that. We cannot say that because n is the position. So what I want you to practice is, let's make a table for these answers. Okay, so I'm going to take the first one and I'm going to try it. Here's my n and here's my number. Okay, if I do n is 1 and I plug it into here, that would be 2 times 2 plus 1. Okay, that gives me 5. Is that what I wanted for the first number? No, right? I wanted 3, so that one can't work. Okay, so I'm going to say, okay, that one didn't work. Let me make another table. I'm actually going to make it over here. So n and the number. If it's 1, it would be 4 times 1 minus 1. And that gives me 3. Oh, it looks like it's working, right? Okay, let's try the next one then. 2. If I do, sorry, let me zoom out because I'm running out of space. Okay, if I do 4 times 2 minus 1, that's going to give me 7. And that's not what I wanted. I wanted an 8. Okay, so I can go back here and I'm going to cross this one out. Okay, let's try the next one. And since I'm running out of space, I'm going to do it over here. Okay, so n and the number. I'm going to try 1. So this would be 5 times 1 minus 2. And that's going to give me 5 minus 2. So that is 3. Oh, looks like it's working. Let's try the next one. Okay, 5 times 2 minus 2. Let's see if it works. Okay, that would be 10 minus 2, which is 8. Oh, looks like it's working. Okay, let's try 3. 5 times 3 minus 2. That's going to give me 15 minus 2. That's 13. Looks like it's working. Let's do the last one. 4. So that would be 5 times 4 minus 2. So that would be 20 minus 2, which is 18. Did they all work? You bet. Therefore, we got our answer. Okay, now here's the question. Do I have to do every single one? Yes, you guys, because they're going to throw something in there that's going to confuse you. What would have happened if I had stopped right here? I would have gotten the wrong answer because I know it worked for the first one. But in the second one, I saw that it didn't work. Right? Remember, over here, when we did that one, when I tried number 2, it stopped working. So we need to make sure it works for every single one. Then we'll know that we for sure got the right answer. Okay? And last problem, you guys, is this one. Okay, it tells us, guys, that we want to find the expression while they're giving us a table. Okay, so we need to figure out which of these is working. Let's make a table for the first one. So for f, okay, I'm going to make a table. I'm going to do it this way just to save a little bit of space. So if n is 1, so the first number, I want to get 1. Okay, let's see if it works. 1 plus 2 over 3. That's 3 over 3. Do I get 1? Okay, looks like it works. Let's try number 2. So for, again, they're reminding you what to plug in for n, guys. 1 and 2. So for 2, I'm going to go ahead into here, in the n. I'm going to put in the value. So 2 plus 2 over 3. That would be 4 over 3, which if I simplify to a mixed fraction would be 1 and 1/3. Is that what I got? No, right? So far I know that the first one does not work. I'm going to do G. Okay, here's my n, here's my number. First number, 1 plus 1 over 2. That gives me 2 over 2. So far, so good. Okay, let's try the next one. So 2, that would be 2 plus 1 over 2. That's 3 over 2, which is 1.5. Oh, looks like it's working. Yay! Okay, let's try number 3. So that would be 3 plus 1 over 2. that would be 4 over 2, which is 2. And I'm not going to stop because remember, they like to be tricky. They might throw a curveball at me. So I'm going to do that last one down here. So I'm going to say, okay, 4. 4 plus 1 over 2 is 5 over 2. And that is 2.5. Did they all work? Yes, they all worked. So I have my answer would be G. And to finish off the video, guys, I want you to try a couple. This is the first one I want you to try. I gave you the expression. I want you to write the sequence. So make a table, guys, and write the expression. What is happening? So what times n plus what? What am I doing here? Now, actually, guys, I want to do this one with you because here we don't have any multiple choice. On the test, of course, you will. But what's going to happen here is we're adding 3 every time, right? So there's a little trick, and I didn't show it to you before, but this number is always going to be the number that's with n. So this number is going to be 3n, and then I'm going to add something to it. Okay, well, let's see what I need to add. If I do 3 times 1, that gives me 3. Is that the first number that I wanted? No, right? How much more would I need to add? I would need to add 3 plus 4. So I would add 4 more to get there. So that's the number that we're missing. So this would be 3n plus 4. And we could try it out and actually plug in 1, 2, 3, 4 and see if it worked. Okay, how would we do that? Let me show you. Just like we were doing before, guys. 3 times 1 plus 4. Does that give me 7? Yes. 3 times 2 plus 4. Does that give me 10? Yes. And I could check every single one. So again, all that we did, guys, is we saw the pattern. That was the number that goes with n. And then I plug in 1 to see what am I missing. And I was missing 4 more. And that's the number that we plug into here. And that's it. Okay, so we did that first one. I want you to try this next one. So make a table for using this expression. That's the one I want you to try. When you're done with that one, no, just that one, guys. Just try that one and you'll be good, and we'll discuss it in class.